Hi friends. Today we're going to talk a little bit about how atoms differ from what we see on the periodic table. So previously we looked a little bit at how you could take a periodic table square and figure out exactly how many protons, electrons, or neutrons are in one given atom of whatever element you may be looking at. Now we think about this as being a standard, but it's not always the case. Sometimes atoms do differ from that neutral stable atom that's shown on the periodic table. Now, if we think about it, we know that our number of protons is our atomic number. That gives us our identity of the atom. So protons are not something we can easily see change in a given atom. For example, if we think about magnesium, magnesium's atomic number is 12. So it's always going to have 12 protons. We're never going to see that number of protons change. And if it does, if we had some reason the protons changed to 11, we're no longer talking about magnesium. Now we're talking about an atom of sodium. So we can't see those number of protons change. But changing the number of electrons or changing the number of neutrons doesn't change the identity in the same way. And so there are circumstances where either one of these may make a change. And we'll talk a little bit more about why that might happen as well. So let's get started. You can see here that if the number of electrons becomes out of balance, so in a neutral atom for the periodic table, we know atomic number equals protons, which also equals electrons. However, sometimes these electrons and protons come out of balance. It means that they're no longer equal. And now we may have more protons than electrons, more positives than negatives, or vice versa. We may have more negatives than positives. So the atom can become charged overall. It has a charge now, either positive or negative. And in that case, we are going to refer to it as what we call an ion. Okay? I-O-N. That word you should now connect in your brain. If you see an ion, that means it has a different number of electrons than it does protons, and that atom is charged overall. What do I mean by charged overall? Okay, let's talk about that. So let's go back to our friend magnesium that we were just talking about. Magnesium's symbol is Mg. Okay, so if you saw Mg just like that, you would think, oh, that's an atom of magnesium. Let me go to the periodic table, and I can get my proton, electron, neutron count from there. But if you were to see magnesium 2 plus above it, a little superscript, okay? Now you can see that magnesium is not just magnesium anymore. It has a charge, okay? And this charge indicates to you, this little 2 plus, that there is something going on. It's no longer balanced in terms of its positives and negatives. In fact, in this case, we would end up with 2 more positives than negatives. So we have a charge of 2 plus. We have more protons than we do electrons. So in that circumstance, we call that, friends, a positive ion. Now, we also could make a negative ion. And in that case, something like chlorine, for example, Cl, tends to make an ion where it'll take on more electrons. So you start to see, instead of having a plus, you see a minus. And if you only see a minus sign with no number, what we want you to do is assume that that's a 1. Okay? So this would be Cl minus 1. And that means that we have more electrons than protons in this balance, and that's going to be a negative ion. And we'll find out later that these ions form because they have different levels of reactivity. And then also, ions can start to come together and make some of the compounds that we're going to talk about later as well. So, really, what do we need to know? We want to focus on the fact that an element becomes charged when its electrons become out of balance. Okay, so we have the electron number changes and now it's no longer equal to my protons. And if that happens, we have a positive ion or a negative ion. Okay, excellent. Now we talked about the number of electrons changing. Let's move on to talking about the number of neutrons changing. When we think of a neutron, what is it? What is a neutron? It doesn't have a charge. It's not positive. It's not negative. It's neutral in charge. It has no charge. So that's not going to change the charge of my atom. If I add something neutral, no charge changes. All we're going to see change is something, if we have more particles, then the mass is going to change. The mass is going to go up if we have more particles, if we have more neutrons than we should. And if we have less neutrons than the periodic table shows us, the mass is going to go down. In that circumstance, we're going to call that an isotope. I-S-O-T-O-P-E, an isotope. So an isotope is when the mass of the atom changes from what we see reflected on the periodic table. And generally, when we see an isotope, we're going to see it written in this way, this form right here, where you see oxygen-17, which you can see as the element name dash the atomic mass. So if we were to look at the periodic table square for oxygen, you're going to see that it says what as its mass? 15.999. So we generally tend to round to the nearest whole number. So a normal atom of oxygen would have a mass of 16. So that would be oxygen 16. But when we have oxygen 17, that's going to indicate to us that our mass has changed from the normal status. Therefore, we must have more neutrons. We have one more neutron. If we were oxygen 15, that would mean we have one less neutron. So let's try to look at this. You may also see them written this way. So we see it this way, oxygen-17, which that represents my mass number. Or you may also see it written this way, where we use the symbol, we put the atomic number below and the mass number above. And if this mass number differs from that normal atom right off the periodic table, then we're talking about what we refer to as an isotope. So isotopes here, where we would write them very similarly. We'd put our 6 down here. If we look up the periodic table, our atomic number for carbon is 6, so that would go down here. And then I would take my mass from my isotope and put it above. That is an indication that we have an isotope. It doesn't change the behavior necessarily, it's just changing the mass. So we don't see a charge. Okay, great. So let's test this. Let's think about, do we know what that really means? So let's go for a normal atom of carbon. If I go to the periodic table and I find a normal atom of carbon, it's going to have a mass of 12. Actually, it has a mass of 12.011, but we're going to round that to 12. And it has an atomic number of 6. So that tells me right off the bat, I have 6 protons. How many neutrons do I have? I also have 6, because if I take 12 minus 6, I'm going to get 6. How many electrons would I have here? I'm going to also have 6, because I'm in a neutral, balanced atom from the periodic table, a normal atom. So let's start down here. Atoms with different numbers of neutrons. Which of these things would that be? If it has a different number of neutrons, if we're changing the number of neutrons, if you said isotopes, you're right. Okay, changing the number of neutrons makes an isotope. Okay, so our isotopes, if we remember how they're written, we have carbon 19. So I'm going to cross out isotopes. We use that. Okay, so we have carbon 12 is our normal. If we have one less neutron, that's going to drop our mass by 1 unit, and that's going to be carbon 11. So we're going to type that in here too. Carbon 11. That's my example of an isotope that has one less neutron than normal carbon. One more neutron is going to up my mass by 1. So that is going to be carbon. Okay, let's move over here to this side. We're now going to take a look at atoms that have gained or lost electrons. We refer to those as ions, right? Ions are what we have when we have a an unbalanced misalignment between protons positive and electrons negative. So we've now used carbon 11 and carbon 13. We should automatically have in our minds that, that if we see the word ion, we're going to have a charge on our atom. Charged ions, okay? So if we have one more electron, are we going to become C plus 1 or C minus 1? And if we have one more electron, that means we're becoming more negative than positive. So that's going to be C minus, okay? C minus 1. And that should be a little minus 1. So let's make that tinier. Let's put it up where it belongs. C minus 1, okay? If we have one less electron, we're going to become more positive, C plus 1. And again, this is going to be up where it belongs to recognize that it's a charge on that atom. Now, these are not ions that carbon really actually makes in reality very often, but it gives you an example of what that thinking should look like. So now we have boron and nitrogen. And now what we're going to look at quickly is the fact that if we change the number of protons, we're changing that identity of the atom. 6 protons, is going to always be representative of carbon. If we go one less proton, we now have 5 protons. And so we're looking for an atom with the atomic number of 5. That's going to be boron, looking at the periodic table. So we're no longer talking about carbon. We're talking about a whole new substance if we change the protons. One more proton is going to take us over here to nitrogen. Okay, so if you're able to put this chart together and show your thinking, you should be able to understand what's going on with any individual atom. If it's changing its number of neutrons, we're making isotopes, and we're going to see the mass number change. If we are changing the number of electrons, we're going to have ions, and our atoms are going to become charged overall with these plus or minus charges. And if we were to change the number of protons, we're going to end up changing the complete identity of the atom to something completely different. So we don't change protons, only neutrons when we're talking about isotopes, and electrons with ions. So hopefully that was helpful, and we're going to go ahead and move forward and understand how some of these things may exist in nature.